Yeah, when I was here in February, I had the opportunity to speak to to another DDD community, or a somewhat more local DDD community, about all the good stuff that you could do. So I thought next time that I'm here, let's talk about all the bad stuff. Let's talk about all the annoying stuff that me and some of my customers had to endure. So in this talk, I'm going to give you about a dozen reasons why you would never, ever want to go into event sourcing. And I will also give you 3 reasons to ignore those other reasons. And hopefully, you'll be able to make a decision for yourself after this talk. So a bit about, well, not too much about me, but about my surroundings. I think, like many of you, I have created lots of big balls of mud. Some of them are still in use. We then call them legacy applications, I guess. Some of them have been torn apart. And, well, that happens, right? But I don't mind making mistakes. I love making mistakes because they're beautiful learning opportunities. But as soon as you make the same mistake twice, it just means you missed a learning opportunity, AKA, you're kind of stupid. I am. And I don't like that. So I try to find, okay, what am I doing wrong, and why is this happening all the time? So I started to investigate different ways of structuring applications, and I came across what is now called CQRS. And that's a very interesting concept. And the concept, as it was explained by most people, was quite closely related to event sourcing. And as I started experimenting with CQRS, I accidentally created a framework called Axon Framework that was launched in 2009. And Axon Framework builds upon the principles of CQRS and domain-driven design. And another very important aspect is that of location transparency. I have found that it's very important for applications to be built up of components that are not aware of their location in respect to other components that they communicate with. As soon as that communication is done in a location transparent way, you gain a lot of flexibility to evolve monoliths to what we would call microservices. But of course, it also entails event sourcing, and that's what I'm going to focus on today. So last week we finally got some download results. We get every month we get our statistics, and I wanted to share with you that last month we have crossed the 1 million downloads barrier. So that was a reason for us to celebrate. So event sourcing, what is event sourcing? Just to get a bit of an understanding about who you are, who of you has heard or knows what event sourcing is? Who of you was pretty sure they have no clue what event sourcing is? Okay, cool. So event sourcing is, there's a lot of definitions and explanations going around, but they come down to more or less the same thing. Event sourcing is an architectural pattern in which events are considered the source of truth, based on which components rebuild their internal state. So it's taking this concept of an event to a somewhat higher level, right? It's not just a notification that something happened, but it's going to be the source, right? We're just listening to those notifications in our architecture. So when I read about event sourcing on blogs, and especially when there's certain technologies involved, I get a definition that's somewhat similar to the one I just showed you, and then an explanation of, oh, and this is then how it works. And basically it comes down to you have an event producer, and it has a model. It probably has some state that is stored in some database, and there's another component which is an event consumer, and it also has state, but it builds that state solely on the events published by the event producer. And they said, well, that's event sourcing, period. I'm not really on board with that, actually. Event sourcing is slightly more than that, because if those events are the source of truth, how true is that source of truth if that source of truth is not the source for the event producer? Right? It might be a side effect. Who can guarantee that your truth is true if it's just a side effect of something else? So how can you guarantee that this truth is really the truth? Well, the only way to really do that is to make sure that you basically feed those events back into the event producer and make sure that the event producer uses that to update its state. So the event producer should also use the event it publishes to rebuild its current state. And eventually that state just becomes a list of events or a collection of events that it has emitted in the past, and it uses that history to rebuild or to make its decisions, right? If you use a structure like this, then basically that whole storage of events, which we might as well call an event store, will then become the source of truth because everybody bases their decisions on what's in there. Right? And usually when I explain this, this style of architecture, and especially with events, people start asking me, yeah, but how do I do this thing that was a no-brainer back in the layered architecture times? I mean, back in the current way of doing things. What if I just have a layered architecture with this big, massive database that holds my source of truth, right? The state is the truth. How do I deal with stuff like consistency? I mean, there's a lot of questions about the theory on how to work with this, and well, DDD comes with a lot of answers for us, and if DDD doesn't provide answers, at least it provides guidelines. And in this case, an aggregate is a very clear consistency boundary, right? So when we publish events, and we have this unit of consistency in there that makes decisions for us. So we can at least make sure that when we publish an event, that is a consistent, it's based on a consistent model, right? There's no other decisions that we don't know of that might have impacted our decision in the first place. And with event sourcing, you would have an event stream, or essentially it might be a substream depending on which implementation you prefer. It doesn't matter that much. Conceptually, you'll have an event stream for every aggregate. So every aggregate will have its own history. And you can add more decisions on the end of it. Preferably only one at a time, or not one transaction at a time, so to say. Otherwise, it's difficult to ensure the consistency of your aggregates. And the whole transaction is the publication of events. There's nothing else happening, right? The only thing that the aggregate in this case will have to do is publish some of the events, and that's it. That is the transaction. Consuming the events is a completely different transaction, right? So that allows us at least to have different consistency boundaries, one on the producing side and one on the consuming side. And yes, you'll have eventual consistency between the two. And that might be something that we need to live with, to learn to live with, so to say. But eventual consistency is already, I mean, the biggest problem here is data stillness, right? How can we guarantee that when we do a query, that we get the actual current state? Well, that guarantee never existed anyway, because by the time the information is rendered on the UI and your brain has interpreted all the information that's there, it's going to be stale anyway. You have no guarantee that anyone else has updated that information. Then there's some issues around batch updates. So if you have an event stream per aggregate, how do you update them all in once? I mean, right now we have this big database with our source of truth, with our canonical domain model, right? It holds the true everything, and we can just update anything we want. We do one SQL update, and everything is back up to date again. How do we do that now? Well, I'm going to repeat myself. Well, your aggregate is your consistency boundary. If you choose an aggregate as a consistency boundary, that means that you have not chosen the system as your consistency boundary. So that means an update in this case will involve a lot of updates in different streams. That might or might not be an issue in the environment you are, and if it is, it's either because event sourcing is not your way to go, or it's because you've made a modeling mistake in your aggregates. There's a lot of options. And this is one that I get actually quite often, and I love this one, because it gives me the opportunity to practice some stares, like some expressions of, oh my God, are you really saying this? So there's people saying, well, we want to do event sourcing because we want a source of truth. We want to have some form of audit log of everything that happened. Oh, that's cool, you can do event sourcing. So then you do this and that, and then that's very reliable because you can guarantee that your audit log is actually correct. Yeah, but how do I tweak my data in the meantime? How do you mean, tweak the data? You want an audit log of exactly what happened, and then you're tweaking it on the side of... Go ask your auditor how you do that, and then we'll talk. So why do you want to do event sourcing in the first place, right? And at first they look at me like, come on, you know that everybody needs to update the data to fix an application, right? If a process is stuck somewhere, the solution is always to flip a bit, right? You just flip the Boolean to true and everything works again. We don't care about any other side effects that we have, that doesn't matter anyway. So the whole thing is you want to leave a trail, right? So essentially if you need to do a fix in whatever data, that's fine, but at least make sure you leave a trail of that fix in your audit log. So append events that can compensate whatever you've done accidentally that was a mistake. Either users pressing the wrong button at the right time, or developers having committed code that wasn't quite what they intended to. But these are all theoretical problems, and this is about learning what event sourcing is about and learning what it can do and what it cannot do. And that's not really the stuff that I like to talk about in this session, although I did. Sorry. Did I just say I'm not enjoying my talk so far? Anyway, there's an array of issues that we encounter when we apply event sourcing in practice, and some of these come in the early days, and some of them come in later stages when it's too far to go back, which is really lovely. So the first is aggregate logic, and this is a mistake I've made when I did my first event sourcing implementation when I was reading about it. And the problem is that I was executing validation logic against past events. And I had some logic saying, okay, I need to confirm an order. And in the beginning I had some business rules, and I wanted to change the rules a bit. So I had some cases in the past where an empty order was confirmed. That's not really useful, right? I want to confirm my order of nothing. Well, you might as well either reject that or completely ignore, etc. And then so I changed the rules, and I said you can only confirm an order if you have at least one item in it. And I wanted to reload some orders, and they failed. Because an order confirmed event was being loaded, and I said, well, I can't do that. And that's wrong, right? It happened in the past. You can dislike something that happened in the past, but you'll have to deal with it. You cannot ignore what happened in the past. And the trick was to separate the decisions from the state changes. Something that is probably very obvious to hopefully most of you, but it became painfully obvious to me around 9 years ago when I was playing around with this. So this is some code examples of the way Axon would handle it. Of course, it will be very similar in any other way of doing this. So the problem was really in that assert, right? Assert a minimum value of our order. What if these rules change, right? What if it goes from something to a minimum of at least one item or whatever? And the trick is really to separate that logic into two parts. So the top method here is the command handler. This is the part that makes the decisions, whereas the bottom method is the event sourcing handler, which is the method that just updates state. And this separation is very important because we do not want to make any decisions when we are loading or reconstructing the aggregate state of past events. And we do not want to have any state changes in our command handler because we will not be reapplying those state changes when reconstructing an aggregate based off past events, right? And it is actually very easy to make a mistake in here. It's very easy to say, just before the line apply, you could say, well, the status is confirmed now. Or I have a set of items, I'm just going to add an item to it, or whatsoever. So it's very easy to make mistakes, and of course we provide means to help you detect those mistakes, and we have test fixtures that will happily fail for you if it detects any state changes in a command handler or any decisions in an event handler. And this type of code might look very weird to you, very strange, because you're used to doing state changes in your command handler methods. But I've spoken to a lot of people that have been applying this for a while, and when they went back to what we call a non-Axon project, for them it was really strange to actually do state changes in command, essentially command methods directly. So that's something we can probably overcome, and we need to get used to that, etc. And then there's a lot of problems around event design. So who of you has ever written code, and when you go back to that code half a year later, or maybe longer, you have this feeling like, oh my God, which beep wrote this code? And you do git blame, and like, oh no, it's me. Or at least the feeling like, what had I been drinking the night before? Well, imagine that, but then on the structure of your events, not a half a year ago, but 5 years ago. And I hope you have this experience of looking at old stuff you've created and thinking, ooh, that was dumb, because it means you've progressed, you've gotten better at things. But the problem with event sourcing is, especially if it's an audit trail, you're not supposed to change it. Yet you're making progress, or your business is changing. So we need to live with whatever we're inserting on day one. We are going to need to live with that forever, at least for the lifespan of a certain application, which may very well be forever. And that's a pretty big commitment, right, that we're going to. And what I want you to realize is that events are part of your model, right? They need attention. They need the same, if not more, amount of attention as the aggregates that you're designing or the rest of the model, right? Because you're going to be stuck with this for a long time. So just use these DDD practices that we've been talking about for 2 days now, or a lot longer actually. And apply those to events as well. And techniques like event storming already, they start out with events, so they give events a lot of attention in a modeling exercise, which is a good thing. Now, when we use those events in a microservices environment, or at least in a distributed environment, there's some additional challenges here, because it's not just you that has, or your future you that has to live with these events, it's them as well. And you can be kind to yourself, but they might not like you messing around as much as you do. So every time you share an event, you get coupling with some components. Now the problem with events is they are pub sub, right? You raise an event, and any component that wants to listen to that event can pick it up. And I think there was a there was a talk yesterday comparing coupling to a marriage. Well, imagine being married to many partners, but not knowing which ones. That could be pretty annoying. How do you file for a divorce? I'd like to divorce. I don't know who from, but as many as possible. That's difficult. But yet again, there's solutions and there's techniques we can apply, and a lot of them are already applied in microservices, like consumer-driven contracts. If you consume an event of that a component publishes, write a contract or write a test case that explains to the publisher how you intend to use that event and when you expect that event to be published. Right? Be sure when you do this to be very strict on what you expect. Right? You don't want to say, I expect an event with all this data, but what we really only need is this and this. Right? Because you're locking them into that structure for no reason, really. So consumer-driven contracts is at least a good way of signaling, you know, I'm trying to make a change, and oh, there's somebody I was married to that is objecting to that change. At least now you know who you're married to. And then there's these rules for forward and backwards compatibility that you can apply. They are really annoying, but not as annoying as a very angry partner. I'm not going into the rules too much. A lot has been written about them. But there's another thing when sharing events with other components. So I think it's very important to realize the scope in which you're sharing. Right? Sharing to the world or getting married to everything out there is a big problem. So you want to scope it down a bit. And again, DDD gives us nice tools to do that. The bounded context. And in his keynote on Wednesday, Eric asked, what is the relationship between the bounded context and microservices? Well, here's, I think, one relationship. And events are part of your shared language, right? And we have to be very careful with the language that we share, and especially who we share that with. So imagine every component can just publish to any other component, right? You share your language with the world. And imagine there's a shipping module here, and the language that they speak or understand is order placed. Now that's the terminology that they've been using in that department for ages. And when an order is placed, we prepare our shipping. But that's not really what happens in the order department. In the order department, it's like, yeah, well, order placed. No, there's a lot more to that, right? It's not as simple as you think it is. Because an order is created, and items are added, items are removed, there's shipping addresses assigned to it, there's billing addresses, and then when it's confirmed, then it's kind of what probably you would call placed, right? But the order confirmed is probably only just a flag saying, hey, that order is now confirmed, we're good to go. So that means when the shipping module wants to know when an order is placed, they care about all the items in the order, right? So they would have to listen to all these item added events, all these item removed events, and do the math on them, which might not be very hard in this example, but I'm pretty sure there's a lot of examples out there where it's really difficult to replicate the behavior. And it's annoying. We're replicating behavior. That's not a good thing. So we take the bounded context into account. And when we do that, we can organize. Of course, it looks a lot less messy if you draw it this way as opposed to the other way. But this is more about within a context, you can share your events. Because within a context, different services or different components, it might be one microservice or one monolith, if you will, doesn't matter, that has a number of components in it. But they speak the same language. They understand this language of shipping or of orders. So it's fine to share. But in between bounded contexts, you want to be sharing more consciously. So let's take the example back of the order placed and the order confirmed. There's a little purple ball just on the edge of the bounded context here for orders. And that's a good place to do a translation of your internal language to your external language, right? What is a language that you don't mind coupling to when components from other bounded contexts need to interact with you? And this is very similar to the anti-corruption layer, but when reading about the anti-corruption layer, it was more about keeping corruption from the outside from coming in. And this is more about marriages not going to the outside, right? Restricting who you want to get married to. But it's the same concept, right? We want to make sure that the coupling that we might be enforcing on ourselves is limited to people that actually understand the meaning of all these events. And hopefully that also means when you want to change those events, that those people that you can communicate with are either very happy with a change and are willing to either contribute or go along with it, but at least that you know where to find them and that you have a common policy on how you want to deal with changes of these events in the future. And talking about changes, there's another challenge there, is that if you change your event structure, of course you have this risk of breaking consuming services. And we talked about consumer different contracts, but there's also something very important to realize, especially when you use certain frameworks like ours. It's usually events are created using, in our case, Java, or just in a programming language. You create an object, and you assign attributes to that object, etc. And you go like, okay, that's our event, and that's what we publish. Well, that's not true. That is not what you publish. You don't publish objects. You publish the serialized form of that object. So you want to be very conscious about the form in which you actually share your information to the outside world, right? There's an convenient/inconvenient default in Axon, which creates an XML serialized form, but the serializer that's being used by default creates a type of XML that is pretty much tied to the implementation of the class, which is very convenient because that serializer is able to serialize everything and deserialize it back. But for interoperability, it's not the ideal thing you want to choose. So be very careful about the structure of the information you share. And I'm aware that different languages go about this in a different way. So if you're in a language that does that a lot better, I'm very happy for you. Now, one of the bigger issues I see of event sourcing is it elevates this event to a higher level. And you know, if all you have is a hammer, everything starts looking like a nail. So I see a lot of applications that use events everywhere. All communication through events. I was approached by a large bank a couple of years ago. They said, well, we like this, we like Axon, we've been applying it for quite a while, and now we're really looking into expanding our usage of it, and we've been thinking about it, and we want to enforce a set of rules on all of our applications. And one of the rules was all communication through events. And they said, what do you think? And I'm Dutch, which means I'm very direct. I'll tell you I don't like it straight to your face. And that's what I did. And it scared them a bit, like, oh, you know, I'm the senior VP of architecture. You're telling me that this is not right. Well, I was able to explain the problems of what was happening. Because events are just one of the means to communicate, right? There's different reasons to send a message. And it's important to also realize the concept of commands and queries, right? Are you telling a component to do something? There might be a good reason to tell a component to do something, right? And there might be a reason to ask for information. Here's a little example to illustrate that challenge. Imagine we have an order service and a service that needs to know about these ordered items. And these are the events that are created. Basically, it comes down to the problem that I spoke about earlier in the bounded context. Is the logic is being copied. And this is where I realized that having the same foreground and background color is not very useful. Essentially, there's a lot of logic being copied from the order service about what it means for items to be added and items to be removed. What does that mean for the state of an order? Well, the component on the right will now also need to understand that. So there's a lot of duplication of logic. But I've seen some examples that are much worse. So let's say an order service says, hey, I've created an order. Well, there's nothing wrong with that, right? There's nothing wrong with an order service emitting an event that an order was created. The problem here is that the intent of sending that event is for the shipping service to do some work. And the order service would wait for the shipping service to come back with a response. And of course, a response is also an event because the only thing we have is events. And then the order service says, oh, yes, I'm ready for payment now. Well, it's pretty obvious what the expectation of that event is. The expectation is that some payment service is picking it up and sending an order paid event back. And then the order service, okay, I'm ready for shipping now. And the shipping service, oh, yeah, I'm shipped. Now, the problem here is that the goal, at least so this is literally an example that I was given, like, hey, we use an event-driven architecture, look what we do. And I was like, yeah, but you're using events to reduce coupling of components, but you haven't removed any dependency. All you've done is invert the dependency. So instead of the order service literally knowing there's a shipping service and I'm going to tell it to go ship this stuff, now I'm still relying on that shipping service, but I'm just not pointing at it. It's pointing at me. It's listening to me for this event to happen. So basically, we've just inverted the dependency, making it a lot more difficult to find out what is going on. And it's very clear here that the order service has expectations of what should happen right now, right? It's involved in a specific process. So we see different types of messaging. I was corrected yesterday when I said I was speaking to Matthias. Is he in the room? Oh, it's recorded, Matthias. You were right. And he said, no, there's more than 3 messages. How do you mean? Yeah, well, there's a subscription. I said, okay, yeah, that's subscription. So that's the message you send when you want to start receiving events. Okay, I understand that. So basically, there's 3 categories of messages, which are events, commands, and queries, because a command usually has some form of a reply, which is either an ACK or an ACK, or maybe you want a bit of information in there. Be careful when you do that. There's a query, and of course, a query has a response. A query is a message where there's no value in you asking the question. The real value is in the response that you get back. Right? And these messages follow different patterns. So the events in the middle, they're a typical publish, subscribe kind of pattern. You send an event, you're not waiting for any response. There's no coupling in time, right? You don't care when that event is being handled. That's all right. Typical pub sub. In a command, you typically want to know that a command has arrived at some point and maybe get an acknowledgement of, okay, your command actually makes sense given the current state of things, or it doesn't. And it would follow a consistent hashing kind of pattern when you have multiple destinations you want to send them to. Commands for the same order, you would want them to go to the same destination. So you can optimize for performance in that destination. And queries, we have 3 different patterns for queries. The point-to-point, where you just have one destination answer your question, which is very useful if you have a single authoritative answer to your query. Whereas in some cases that's not the case, and you would want to ask a question and get different opinions of different components. And you get a lot of responses, and you decide, okay, you reduce that collection of responses to a single response that you would like to use. As I said, I'm Dutch, so we like the lowest price. So you ask, what's the price of this? And you get different answers, and you pick the cheapest one. That's what we do. And then there's a subscription query, which is more or less, keep me up to date on, right? Give me this, this view model, and every time something changes, send me an update, so I can keep my view model here as a replicated copy of the view model over there. Then there's the challenge of event evolution. As I talked about, we want to change the structure of our events, because the version of ourselves 2 years ago did not realize that something. So we need to change that event structure. We want to be able to do that because we definitely do not want to be stuck with our 1950s decisions. And there's some techniques that we can use. There's Upcasters, which can convert old events to old formats to the new format. And then there's these rules of forwards and backwards compatibility. And generally, you'll have to apply both rules to be able to adapt the events. Now, a very naive approach that I've seen once, fortunately not a long time ago and haven't seen it since, is to have a class for every version of an event that you would have. And that's really beautiful because it will create event handlers for every single class that you can possibly have, which is really annoying. So the thing we really want is to be able to move from one representation to the next. But of course, the object that we have, that is not the shared representation, right? That is not the representation that we have to live with. It is the serialized version. And basically, the Upcaster is a mechanism to transform the old serialized version to the new serialized version, which we can then read into the classes that we would like to use. Right? But things get more difficult. What if we want to change our aggregate boundaries? Remember that every aggregate has its own little stream of history. When we change that, we will have to restream events, right? We have to split an event stream and decide, okay, which event belongs to what new aggregate now? I haven't come across this a lot in practice. I think, again, only once, and it was not really a nice thing to do. So this is definitely an area where I think we as a community, hopefully, can find ways to do this better. One way is to reassign every event to the new aggregate, right? Just split the stream into two and decide which event was related to which aggregate, which new aggregate. Or the other one was just create two new streams, and the start of that stream points to the previous, saying, well, we just have shared history, right? We used to be one in the past, so we share history, and now we are two, and we each go on our own different ways. So GDPR came along not too long ago, although we had 2 years to prepare. But of course, people only take 2 months to prepare. It's like, it's going to be in May. It's March now. Maybe we should do something about this. So there was a lot of panic, especially when using event sourcing, because you store everything, and everything is immutable. How do you remove data from an immutable data store? It's actually very easy. And one of the solutions is, well, don't store your sensitive data in your event stream. Store it outside of it. It's possible. You can do that. It just makes consuming events a lot more annoying, a lot more awkward, because every time you just get an object reference or a reference to some piece of information, you have to go to another system and get that piece of information if you're interested. And especially when that person has decided, forget about me, you'll have to deal with defaults. Another approach is to encrypt all sensitive data using typically a symmetric key. And you'll have a key per subject. So for every person, and maybe within the context of financial information and in the context of personal profile. Because for financial information, you have different rules on when you need to delete that data. And when you want to forget about someone, you just erase the key. That's a rather simple thing to do. Actually, so simple that you have to be careful not to do it by accident, because you will never, ever be able to reconstruct that encrypted data. Well, don't say never, ever. There's quantum computing coming up, but still, a colleague of mine did some calculations, and if you have not sure if it was 1 million or 1 billion quantum computers, it would still take you probably 1 million years to get a piece of information back. And that's just one field. So that's another way of saying don't worry about it. Now, when you have large event streams, reconstructing aggregate state can become slow. Well, we can prevent reconstructing aggregate state by using caching, right? If our system uses correct routing patterns, we can cache a lot of information, and we can use snapshots to prevent having to read information from the past. I'm going to skip some details about snapshots for the sake of time. I'm sorry. If you want to have more details on this, come on over and I'll happily explain it to you. And then there's this very practical problem of relational databases that are typically used to insert data. They become slower when you insert a lot of events, right? We have customers with billions of events in their event store, and putting that naively in a relational database just makes it awkwardly slow. They do not deal with that very well. So what do? We use NoSQL, right? They are very good, they're scalable, they're performant, and they're problematic, especially when using event sourcing. And that has to do with what kind of operations do we expect from an event store? Well, we want to be able to append. Well, every database can append. Sometimes they call it insert, but it doesn't matter. If we insert at the end, we have an append. But you also want it to validate some sequence, right? If you have two events going to the same aggregate stream and they want to be inserted at the same position, you want one of the two to fail. You want some form of optimistic locking to make sure that your consistency boundary stays consistent. A lot of NoSQL databases have shown to be unable to do that. We want to be able to do a full sequential read, right? Components that consume these events need to consume the entire stream, everything that happened. And we also want to be able to load the state of a single aggregate and reconstruct the state of an aggregate by loading the events that are related to that specific aggregate. So we want to be able to quickly find within that large stream the events that were related to that single aggregate. Fortunately, there's purpose-built event stores now. They do this a lot better. If you're serious about event sourcing and have large volumes of data to manage, I definitely recommend looking at them. Another solution is to use partitioning and archiving. As you append events, you can start storing them in a different location, and as you have multiple locations, you can start archiving old events, right? So you can partition your streams and store old partitions on cheaper disks to make sure that your database still works fast enough. Then there's replays that take a long time. There's some customers of ours that say, well, we do a replay every time we deploy a new version just to rebuild all of our view models, but it's taking longer and longer. Yeah, duh. You're adding events. Of course it takes longer. Why do you do the replay all the time? Yeah, well, then we don't have to think about doing migration and stuff like that. Well, maybe it's time to start thinking when doing migrations and realize that the old SQL update queries and updating and transformations, they're still there. You can still use them, right? The fact that you can do a replay doesn't mean you have to. So with event sourcing, there's a lot of challenges when adopting it. There's challenges when designing your system. There's challenging when running your applications. There's challenging when evolving your applications. So all this trouble is not worth it. Well, it might be, because there's a lot of value in events, right? Events are a very natural way of reasoning about behavior. So natural that we have event storming. It's a perfect technique to think about system. There's a lot of value in history. You can use it for auditing, or at least transparency, right? Auditing is a pretty formal thing, but it gives you a lot of transparency of what happens. You can add new view models retroactively, right? You have the data of day one. You can use that. And I've seen some really nice examples of predictive analysis being done on events. You can predict, essentially you can start predicting the next event that will show up. It's not as detailed as that yet. And there's a lot of supportive tooling out there. There's great techniques, there's tools, there's frameworks, etc. I would urge you not to be afraid to use them. Don't be afraid of frameworks, don't be afraid of tools, but be careful though. You don't want them to lock you in a place where you don't want to be. So it might very well be worth it, and actually it will be worth it if we provide feedback to each other all the time, if we share the tools that we have created to resolve all those issues. And that's basically my call out to you. If we do that, then event sourcing will become a breeze to use. Thank you.